Hello friends, welcome to my YouTube channel. Today I will walk you through some important concepts of C# programming. So here is the list. What is binary bits? What are other remaining types of operators, which was pending in my last lecture. So I will cover the remaining operators in today's lecture. Next one is what are bitwise operators. First, if we want to move to the bitwise operator, first we have to learn about binary bits. So these are interlinked with each other. So first we have to get the exact points on binary bits, then we will cover this bitwise operators. And next we will cover what are ternary operators, null-coalescing operators, what is type checking and casting operators. So these are all topics we will cover today. So let's begin. So here is the first topic, that is binary. So binary is a number system with only two digits, that is 0 and 1. Binary contains only 0 and 1 digits, and each digit is suppose if we are talking about 0, that is a bit. So single digit is a bit, and 0 1 which contains that is binary. And next one is binary uses power of 2 like this. So what it is, binary is a number system. Each position bit represents a power of 2 starting from right to left. So if we are calculating binary digits, and then it starts from right to left, not left to right. So here is the position of binary bits, this is a position starting from 0 to 7, and here is the power of 2, 2 power 0, 2 power 1, like that, 2 power 7. And here we call this binary places values or binary positional weights. It starts from 1, 2, 4, 8, 16, 32, 64, 128. So these are the binary places values. So why learn binary? Because bitwise most operators work directly on the binary representation of numbers. As I already told you, if we want to learn about bitwise operators, first we have to cover this topic, that is binary. So if we understand this binary concept, then it is very easy for us to learn the bitwise operators. So let's move on. So here are some binary examples. If we want to convert decimal to binary, then we should see this example. Suppose if we have some number 204, we have to convert it to binary. Then we can see step by step. First one, we have to subtract the largest power of 2 that fits with this given number. So here is the binary places values which start from right to left. First one is of 1, 2, 4, 8, 16, 32, 64, 128. These are the binary places values which we want to subtract it from the given number. So here is the given number 204, and here is the 2's largest power, that is 128, and after subtraction we get 76. And here 76 we have to subtract it from 64 because it is the largest, but it is less than 76. So we have to choose this 64, and then after subtraction we get 12, and after 12 we have to subtract it from 8, that is less than 12 number, and but here it is the largest with the according to this number. So we after subtraction we get 4, and after 4 we have to subtract it from 4, we get 0. Then which values we use for subtraction, we have to get those values, like 128, 64, 8, 4. So here is the conversion, that is this is the binary values which we get. Here is the conversion starts from right to left, that is 1, 2, 4, 8, 16, 32, 64, 128. And here which values we used, just use that 1 for that value. We choose 128, so we set 1 for that, and 64 we set 1 for that also, and 32, 16 we do not use that. 8, 4 we set 1 value for that, and 2, 1 we do not use, so we put 0 on these. So here is the binary conversion, which values we used, just convert it to 1, and which values we do not use, we can just simply put 0 on that. And here is the thing, binary works on only 0 and 1. So here is the binary value after conversion of 204. So you can see here this one example, this is the 204, and here is the binary after conversion. Next, one more example we have, that is the number 150. Here is the binary places values, and we have to subtract the largest power of 2 with the given number, that is 150. So we use 128, and 16, 4 and 2. These binary places value we use for subtraction, because these are the like 2's largest power with the according to the given number. So here is the thing, like we use 128, 16, 4, 2 binary places values, and here is the value after conversion of 150. Suppose we have 1, 2, 4, 8, 16, 32, 64, 128. We use 128, then we simply put 1 on that, and we use 16 and simply put 1 on that also, and 4 in the same of the number, like 4 and 2 we simply put 1, and which values we do not use we simply like put 0 on that. Like so it created some binary value. Here is the binary value of this given number, that is 150. So I think you understand this topic of binary. Next we have some types of operators which are remaining in my last lecture. So here are the topics like bitwise operators, ternary operators, null-coalescing operators, type checking operators, casting operators. So here is our first operator, that is bitwise. So it directly perform operations on binary bits. So it is good to have, like we have now knowledge of binary, so it is easy for us to understand bitwise operators, and these includes AND operator, OR operator, XOR operator, NOT, left shift, right shift. These are all the operators in bitwise, and it gives the values that compares with binary bits. So here are the example like AND, OR, XOR, NOT, left shift, right shift, and here are the examples like A and B. It is using only single AND, single OR, XOR, NOT, double left shift, right shift. So these are all the examples in bitwise operators, and here is the Visual Studio examples, like it is performing operation on these all operations. Like it is also giving us or showing us the values of binary bits like 0, 1 in this AND or XOR, or in all these we get the values. Now let's see one by one. First one is a bitwise operator, that is for AND operator. We are using here AND operator, and here is the example like int A is equal to 5, int B is equal to 3. Here is the binary bits, like it starts from right to left. So here you suppose 1, 2, 4, 8, 16, 32, 64, 128. So here is are the binary places values. We convert these values, and which values we used with the subtracting with 5. Like here we are using 4 and 1. Like that is like 2's power is greater but less than the given number, that is 5. So less than the given number, that is 4, and after subtracting we get 1, and then we compare it with 1. So here we are using 4 and 1, and this is the binary expression value for this 5. And next we have given value 3. With 3 after subtracting we are using these 2 binary places values, like first one is 2 and then 1. So this is the binary places values final output of these 2 variables. For 5 we have this one, and 3 we have this value of binary. Like you can see here, we have a truth table for these bitwise operators, because this directly works with the bitwise logical truth tables. Here we have suppose A's values, B's values, and A and B. So here is the thing, like it is like a 0 and 1 means true or false. Like here we have false, 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 then false, true, false, true, false, false, true, true, true. So here is a thing, if we want to compare AND operation and perform AND operations with bitwise operators, then we have to use these truth tables. You have to remember these values if we want to get any result from our output. And we have like binary bits in the formula, and we have to get the final result from these with AND operation, AND operator. So here we get like true, true means true. Here is the thing, true, true means true, and false, true means false. So here we have false, and true, false means also false. So we have also false here, and false, false means false. Here is the thing for all zeros. So here we get only one value, that we get it from starting. So here is the example of AND operator in bitwise. Next one we have OR, bitwise OR operator. So here is the same binary places values we get after converting that from 5 to binary, and here converting from 3 to binary. So we get these values from 5 and 3. So we have a truth table for here for OR operator also. Here is like false false false, false true true, true false true, true true true. So here is the truth table. We have to remember this also if we want to get the final output with bitwise OR. And here we have two binaries. We have to get the final output from these two binaries. Like 1 means 1, 0 1 means 1, 1 0 means 1, 0 0 means 0. So here is thing true false or 0 1 is the same thing, and we get here three values like 111, and others are already zeros. So we have to convert these 111 to 7. For this we have here we have to start again from right to left. Like here we suppose like 1 2 4 8 16 32 64 128. Here we get three values, and we have to just add up these values like 4 plus 2 plus 1. So we get 7 final output from these two variables. Like for OR operation we have to perform these kind of things into this, and we get, if we here we get three values, and with this we have to just add up the thing, and we can get easily the output, final output for this. Next one we have bitwise XOR operator. Same here the binary places values, and same here for 5 and for 3. And here is the truth table for XOR. Like here it says false false false, false true true, true false true, true true false. So here we have to remember these truth table if we want to get the final output. Here we have A binary value, B binary values, and we have to perform XOR operator into this. Means we have like 1 1 means 0, 0 1 means 1, 1 0 means 1, and 0 0 means 0. So we get this final binary output. We have to convert it to number. So we are using here like 4 plus 2. 4 and 2 we have values only true. So we only add up these two values. Like it starts from 1 2 4 8 16 32 64 128. So we have only two true values, so we have to add just these two values to get the final output, that is 6. 4 plus 2, that is 6. And here we have a next operator, that is bitwise NOT. Here is the example like integer a is equal to 5, and we have the binary values after converting 5 to binary, same as we are using 4 plus 1, that is 5. And here is the thing, we have a values, that is in binary form, and then we have to convert it to bitwise NOT. If we are using not bitwise, then we have to just reverse that format. Means you suppose we have true, then we have just reverse that to false, and if we have false value, then we have to convert it to true. Like these values, if these are true or false, we have to just reverse that into another. Like for first we have true, then we have to convert it into false, and for false we have to use it as true, and for true we have to convert it to false, and for all these false value we have these true values. So this is the main functionality of not bitwise operator. And here we have the final output, that is -6, that is in 2's complement. So what is supposed to 2's complement? What is 2's complement? Because to get the negative of a number, and for 2's number, like first we are reversing all the digits, that is 1's complement, that means 1's complement. Here we just reverse that format or reverse these all values from true to false, false to true. So this is the ones complement. And second one, that is we are adding 1 to this number, to the given number, so that is 2's complement, that becomes 2's complement. First one complement is flipping all the bits, second one is adding one value to the given number. So here is the rule, you can remember this one for not bitwise operator. Like we have minus bracket start x plus 1, we have this rule. If we want to use bitwise operator, x is like a given value, and we have 5 plus 1, this is first complement. Second one is like we are flipping all the values from true to false, false to true. So these are 2's complement, and this is the rule for using bitwise not. And here we have minus 6 output from this given value from 5. So this is as simple as that, not a difficult one. For first rule is like just flip all the values with from true to 1 or true to false or false to true. And second one is just add one number to the given value and just add minus with that output. So this is the final output with this, and this is the binary after flipping all the values of binary. Next one we have shifting bits. These are two types of shifting bits, that is left shift or right shift. First we will cover left shift. That if we want to get the final output, we have to just multiply the given value with 4, and we have the given number, that is integer a is equal to 5. So here is the binary values, which after converting we get the final value. Like 5 we have used 4 plus 1. So here are the true values and here are the false values we have in this binary. And if we are using left shift, then we have to just multiply the given value to the 4, and if we multiply the given value to 4, then we get output 20. So we have to just flip just shift that true values to left side, because we are using left shift. And here is the thing, we are here using 16 plus 4, so that's add up values are also becomes 20. So this is the left shift, and you can see here for if we are shifting only 1, we are not shifting 2. If we are shifting only 1 for 5 value, and here is the binary values, and here is we are shifting only 1, so we have to multiply it by the given value to 2, because it starts from 2. So we have to if we suppose we have 5 given value, then we have to multiply it with 2, and then we get the final output, that is 10. So after shifting we get this binary values. Like here we are using 8 and 2, and here is add up the values, then we get 10. And if we are shifting 2 values from right to left, so here is the thing, we have to multiply it by 4, and then we get 20. And here we are using 16 plus 4, that is 20. So here is the left shifting. Next we have right shifting. If we want to get the final output, we have to divide here. In left shift we multiplied in there, and then in right shift we have to divide it by 4 if we want to get the final output. And here we have a same value, like a is equal to 5, and this is the binary form of this after converting it from number to binary. And there we are shifting the values to right side, that is right shift. And suppose here we are shifting the values to right, here we have to divide the given number by 4, given number that is 5, and divided by 5, and then 4 we get 1 value. So here is the 1 value we get from this 1. Here we have the example of single shift or double shift. Suppose here we are shifting only 1 value, then we have to divide the given number by 2, not with 4. If we are dividing that given number with 2, then we get 2 in the result. and then is the shifting. Here we are using only two number, like it starts from right to left, that is 1 2 4 8 16 32 64 128. Here we are using only two, so just write down two answer for single shift to right side. And if we are want to use shift the two values, then we have to divide it by 4, so that is the right shift. Then we get the one value or the one result for two shifting. So these are the right shift or left shift or all the bitwise operators we covered. So let's see the practical example of these bitwise. So here is our last lecture code. We just delete it and start with our today's topics, that is bitwise operators. Suppose we have values like 5 and 3, then we have to just display these values, that what will be the output after using bitwise operators. Then we just copy paste these and or XOR not left shift right shift. We can change here also. Not left shift right shift. So this one is for and operator for or operator, XOR operator, not operator, left shift right shift. Now let's see what will be the example of the bitwise operators for and or XOR not left shift right shift. Just run this project and see the output. It is not giving us the binary values, it is just giving us the final output, like 1 2 3 4 7, like that. The numbers it will give only the final value, not the binary places numbers. So here we have the values like for A and B, that is 1, A or B, that is 7, A XOR B, that is 6, and then for not operator we have -6, left shift we get 20, and for right shift we get 1. Suppose you have any doubts, so here we can clarify the result here in this. Like here we have the binary values in this one, but in here we get the final output, that is 1 for AND operator. Okay, and for OR operator we get 7 value with this, and for XOR we get 6 number, and for NOT we get -6. For left shifting we get here 20 number for shifting two values, and for right shift we get here 1 number. So here is the thing, like for AND we have 1 number, for OR operator we get 7, and then for XOR we get 6 final output. For NOT we get -6, for left shift for 20, and for right shift we get 1 value. So here are the all the examples of bitwise operators. One by one I explained you. You can also create some demo on these operators also for your clarification. So these topics, these bitwise operators, I think we cleared. So we covered these bitwise operators. Next one we have a ternary operator. These are the very important topics or mostly used operators in our programming. Ternary operator is a shortcut for writing simple if-else condition. It uses a format condition for value if true, value if false, then it is giving us according to that value. And for example, we have a and b values, return a, like that. For a ternary operator is like suppose if we are using if-else condition. I will discuss this if-else topic into the later videos. But here we have to understand this. If we are using if-else conditions, then it is a shortest way of using those condition into one line, that is ternary operator. So here is the syntax of this. This is conditional operators also we say, like with this question mark with colon. We have condition here like a greater than b, like this, and if a is greater than b we get a first value, otherwise we get second value. And here we have this example that shows int age is equal to 20. So we have the string values here. Age is greater than equal to 18. So age is greater than 18, so here we get adult. Otherwise if the age is less than 20, then we get minor. So let's see the practical example for this ternary operator. Now just comment this code and see the example of ternary operator. Suppose I have some number, some random number, that is 30, and I have to get true or false value according to the condition. I will apply some condition on this given number, that this number will be greater than or equal to 20. Then it will print me or give me the result of true. Otherwise it will give me false. Let's print the result through console.writeLine. Number is greater than 30. Now let's see the output. Now it is printing true value because the number is greater than 20. So here it will give us true value. Suppose if we change the condition and put here less than, the number is less than 20. So what it will print? Now let's see. Now it is giving us false because the number is not less than 20 or not equal to. If we apply equal to also, it is not equal to 20. The number is greater than 30, so it is giving us false value. So this is ternary operator. You can apply any condition with this one, and if you have two conditions, if you want to get a true value or false value, if you want to get any integer value, string value, like that, we can get any kind of values into this. So we covered here ternary operator. Next one we have null-coalescing operators. That operators like is used to handle null values very safely. These are used with the double question mark operator, double question mark equal to operators. It is used for that mostly. If we have any null values with this operator, it will handle all kind of values. Like the null-coalescing operator like provides a default value. If the left hand side is null, then it will give the value from right hand side. For instance, name is equal to input, guest means if input is none, then we get guest result. So here we have some operators of this, like double question mark First one is, second one is double question mark with equal to. First one returns the left operand if not null, else right. So this is the syntax. A double question mark B. Second one we have, it assigns the value only if left is null. A double question mark equal to B. So here we have the example. First one we have a string A is equal to null, B is equal to hello. Then it will print hello because A is null, left hand operand is null, so it will give the value from right hand side. Second one we have that C is null and C is default value, that is default value. We are using only one variable here, only C. Now let's check this one in also Visual Studio. Comment this code. See, coalescing operator. Suppose we have any string value, programmers, and next we have some specific text, that is CSharp. Then we apply the condition and see the output in terminal window. Null-Coalescing Operator. Text. So here we have values in both variables or in both operands. So most probably we will get programmers from left hand side. First let's see the result. It is giving us the output from left hand side, that is programmers, but not from the right hand side. Let's see one more example. If we put here null, then what it will print? Now it is printing C# because left hand side operand is null and it is giving the value from right hand side. But here is one thing, like it is not like assigning right operand value to left side value, because this here we are using double question mark, not with equal to. But in if we are using equal to, then it will assign that left hand operand value to variable. Let's see the example. Suppose if we want to see here, like first one, suppose here we want to see it is assigning the value to first operand or not. As you can see, it is only giving us the C# output, not giving or not assigning the value to null string. So this one is the output of double question mark. Second example. Suppose we have next example with name value, that will be programmers. Another value we have text value, that we have developers. Now let's see the output of this one with txt, and we can put this value into new variable, final output. So we can see the value with this one, like a final output. Now Now comment this one and see the output. It is giving us programmers, final output, that is programmers. Suppose we have a null here and we want to see the output if it is applying the left operand value or right operand value to the first operand or not. Let's see. This one is nm value and this one is final output. Nm value. Just run this one and see the output. Now we have a first value, that is nm val developers, that is already assigned from right to left operand. So we have this nm value, that is string, that is this one is the original value, developers. It is giving from right hand side to left hand side, so it is assigning that right hand side value to the left hand side. So this is the difference, main difference between double question mark equal to or single question mark. So this is the main difference. It also assigns the value from right to left, so it assigns the value from right to left and also giving us the value from right side. So these two values we have. We can also see the difference between these. Suppose we have this one and we are supposing to get this value in third str and get the result here. This one is the name, that is null. Let's see the output of both these to see the difference. Now we are getting value from both these, and first one value is like from name, that is null. It is not giving us the null value or the CSharp value or assigning the value from right operand to left operand. It is not assigning the value in a double question mark case, as you can see. Here we only have one CSharp, that if we apply here equal to also, it will also assign CSharp to the left operand, but here we cannot see any CSharp operand assigning the value to left side. And in the second one we have the output, like it assigns the developer to the null variable also. Here you can see it assigns the value to the null variable and it is the main final output. So here is the key difference between non-coalescing operators of two. So we covered this null-coalescing operators. Next one we have type checking and casting. Type checking and casting operators help check an object's type, convert between types. So type checking is mostly used to check the type of the keyword, like suppose we are using int type, then we can use a type of operator to check the type of the integer, and the size of the integer we can check with these type checking operators. This operator checks if the value of certain type, for example obj is a string. The as operator tries to safely cast to the object to a type and returns null if it is fails. So string name is equal to obj as a string. And casting mainly means like converting one type to another type, that means the casting. So here are two types that I already discussed that in my last lecture, that is implicit casting or explicit casting. Implicit casting is like if we are converting values from int to float, it will automatically detect that value and store that value in float. And explicit casting is like we have to store the value from float to integer, but if we are storing that value, we have to typecast that float value to int value, because we are storing that float value to int value, but it will only get the value, or suppose we have number 33.33, then it will only get before decimal values like 33. After decimal values it will ignores and or remove from the variable, and it will only get or store the value to integer, that is 33, not the full float value. So it is explicit casting, that we have to manually check that type or assign that type, which type we are using or converting from float to int. So here are the operators. As you can see, first one is operator, that checks the type, that it is integer type or string type. As is for save cast, if we have some like a string value into object and we are getting that value from object to string, so we have to typecast it safely with as operator. Then we can use as this type obj as string. Type of and size of is used to check the type of the integer, to check the size of the integer. Suppose we have this example with we are checking integer type and integer size. And cast is like explicit conversion, that is convert from suppose we are converting from double to integer, so that is we have to manually check that type and then assign that value from double to integer. So this is the main conversion, and this types we have is as type of size of cast. Next we have some examples of type checking and typecasting. We have like object value, that is we are just checking the value, that is it is integer type or string type, we are checking this only. And suppose second we have object string value, and we are that putting that string value to string, then we have to typecast it like obj as, this is the variable name, and here we are using operator as to convert it from object to string. And we are here we are just displaying this value, and here we are just getting the type of integer, size of integer, and here we have explicit cast. Now let's see the practical example in Visual Studio. Let's comment this code and check for type checking and casting operators. Suppose we have some object value like this, integer value we are storing into object. Now let's see the output or check the value, what kind of value it is storing into object. Just to see the output data, what kind of value it is storing with is operator. One more thing, it is if we are using is operator, it will give us bool value like true or false. Here we are getting true because the value is storing in object is integer type. Suppose if we put here string, then what result it will display us? Now it is displaying false because it is not a string type, it is integer type. So this is the main difference of is operator. Checking the value. Now let's see the second operator, that is as. Suppose we are storing some string value into this object, grammars, and we want to get that value from object to string. For this we can use as operator. If we have string value, then first we have to convert it, it is like type save. Now let's see the output of this one. String object txt. let's run this program and see the output. We are getting here programmers, as we are storing string type into object, and we are converting this with as operator with the type safe, and get the value or storing the value into string, and we are now displaying the value like we have programmers. So it is type safe. Now let's see the next type. If we want to check the type of or size of integer, then we can check with this, with these operator. Type of int, we can check it. Type of int, and then check the size of integer. So let's see the result. What the type or what size we can get. Here we have the type and size. The type is int 32 and the type is int 4. That is not bits, that is 4 bytes, and 1 byte contains 8 bits. 8 into 4 32. So that the size of integer is 32 int 32. So this is the type of, and this is the size of operator we are using to checking the type of or checking the size of a integer. This is for type checking. This is for checking size of int. Type checking of int. Now next we have explicit operator. Suppose we have some value in double. Okay, in double keyword we have some value. Suppose we have value like this, and we want to convert it from double to integer. So we have to do the casting or the explicit casting. We have to do manual casting with this, and if we want to store this value into these numbers directly, if we are trying to store, it is giving us an error because it is double type and it is integer type, and for this we have to do manual typecasting if we want to store this double type double value into integer. But here is the thing, like it will not store this full value, it will store only this starting 2 digits before dot. It will only store this one, it will ignore this one or release these digits from this integer while we are storing this value to integer. It will only get 33. Now let's see the output of these values. Int values, suppose we have like this nums. Let's check the output of this explicit. Now it is giving us 33. As I already said, it will ignore after decimal values and it will only get the before decimal values into integer if we are converting that double value or float value to integer values. So this is the result of explicit typecasting. Here we cover these all type checking and casting operators. So we saw these all examples with is operator, as operator, type of, size of, with explicit conversions. We see all result. So here we have summary for today's lecture. What we learned today, let's discuss once. First one is binary. So binary is a number system that contains 0 and 1, and each bit in this binary is bits. It is known as bits. So we check all the concepts in binary as we studied about, like there are binary places value from 1 to 128, and it starts from right to left, like it starts from 1, 2, 4, 8, 16, 32, 64, 128. These are all binary places values, and we also saw the example if we are converting the given value to binary. So this is binary concept. Second one, we have bitwise operators. We also perform all the operations or get all the examples with these, with the AND operator, OR operator, XOR, NOT, left shift, right shift. We saw all the example of these bitwise operators. Next one we have ternary operator, that is a shortcut for if else condition. We can write the logic in our one line, and we can use question mark with that and with the colon. If we want to get any value with a specific condition, we have to apply some condition on this ternary operator. Next one we have null-coalescing operators, that is used if we want to get a default value, or suppose we have a null value in the left operand and we want to get the right operand's value, then we can use this null-coalescing operators. And second one we have in this, if we want to get the or store the value from right operand to left operand, we can use double question mark with the equal to sign. Here we have two types of null-coalescing operators. First one is not assigning the value to the left operand if we have null into left side, but second one we can assign the value from right operand to left operand with this syntax. Next one we have like type checking and typecasting. If we want to check the type or the size of the integer, we can use these operators. It is very useful for that. And if we want to use that is operator, or suppose we have some integer value, string value into the object, then we can check that value with the is operator, that what kind of values is contained by object. And as is, like it is used for type safe. If we want to convert or get that value from object to string, and suppose we have string value in object, then we can use as operator. And type of, size of is to checking the size or type of integer. And last but not the least, that is explicit conversion. It is like we are converting the value from double float to integer value, so we have to manually check that type and then convert that type from double to integer. So that is explicit conversion. Let's wind up today's lecture. If you have any doubt related with the today's topic, you can mention them in the comment section. And if you like my video, you can subscribe my channel, like my videos, press the bell icon for next upcoming videos. If you want me to cover some specific topics, for that you can also mention that into the comment section. Thank you so much for watching this video. Bye. Have a great smile day.